In this video, we'll be looking at a feature of nighttune, one of 5 tools in a suite of tools we call Nightstar. The Nightstar suite supplies tools useful for application development, operation, and performance tuning. Nighttune provides a GUI for monitoring and tuning application and system performance. Individual displays for CPU and GPU metrics, and where possible, control, are provided as a substitute for the many command line display and control commands. Let's look at a general overview of nighttune. So this first page we're looking at is the default page. As you can see, there's a couple of areas, several areas here, all representing different information. I could move these around, resize, or actually even create new tabs. You can see I've got a number of tabs up here. Those came by simply saying view, add a page, and then monitoring something new with that information. But this is the default tab that you get when you bring up nighttune. It's got the process list, basically a top output for Unix, Linux systems, everything that's happening on the system. Broken down by user, I'm operating as user M Slater, so we'll open that up. And we can see I've got a lot of stuff going on here. I have one process running in the background, WD. It's a multi-threaded process, so we can open that up and look at each individual thread. You should know that these thread names came from me using an API call to name the thread, and that's usually a good thing to do with a multi-threaded process. So when you're looking hard at the process, thinking about performance considerations, you know what a thread does as opposed to just its thread ID. So it's helpful to do that. But here you can see we can tell what the process is up to, what percent of the CPU it's using, that sort of thing, where it's running, where it's currently running, its CPU affinity, its scheduling class and priority, that kind of thing. On an individual process or thread basis, we can always just select one, right-click, and find all kinds of information about that. So if I look at the scheduling details for that thread, I can see and change possibly the scheduling class. Based on the class, I'll either have a nice value or a real-time priority that I can set. CPU affinity, or the CPU mask that defines that this process is allowed to run on, I can set here. For any of these threads, I could look at process details and see basically the same output here because it's all one process. So I'm looking at memory usage, memory maps, where everything is laid out in there, open file descriptors, the signals that the process is using, Linux capabilities, so things that require a little extra privilege, the environment that the process or thread is running in, all right here, and OS related limits, all right there. So I can drill down to those menus that we just saw. For simple things like simply changing a CPU, I can drag and drop. So we'll notice my threads E and D are both currently on CPU 3. If I wanted to try one on CPU 7 to see how that worked, I would simply grab him and drop him down there. And you can see now that he is running on CPU 7. So while we were talking about this over here, this is our CPU shielding and binding dialog. All right, it's basically telling me what my CPU situation is. I have one chip, I have 4 cores on that chip, and currently all cores are supporting hyperthreading. So Red Hawk sees 8 virtual CPUs there. The shielding and binding, so I can right-click in here anywhere and show my shielding dialog. So here is where I can come along and for each virtual core, shield against individual things like interrupts in general, local timer interrupts, processes. Sometimes I can come along and with one click, let's say, for instance, I wanted to completely isolate CPU 3 and shield him and mark down his hyper-threaded core. I could do that with one click. And when I apply that, well, we have a little problem. It's telling me I can't do that. And the reason is because I have pinned something to CPU 7. You recall when I dropped it over there. So it's done what it could. It's shielding the CPUs, but not marking down CPU 7. Now I should be able to, let me just get back. I should be able to shield CPU 1 from everything with one click. Let's try that and apply, and sure enough, not only is CPU 1 shielded from interrupts, local timers, and processes in general, but its sibling CPU, CPU 5, has been marked down. And that's going to give me the best hard determinism on CPU 1. I can right-click and say expand all and see for each virtual CPU what processes and interrupts are bound to that CPU. So if we go up to 7, we should see, sure enough, here's the guy I dropped on there. And by simply dragging and dropping, that's me saying you will run here and nowhere else. And that's how we got that. CPU usage for each virtual core, just a breakdown of where the CPU is spending its time. A quick look at some of these other tabs. Interrupts. So here's every interrupt on my system and where it's being handled. And I can not only monitor that, but I can affect it. So if I come to my NVIDIA interrupt, for say and change the CPU affinity to everything and apply that, so now the CPU will be handled, this IRQ will be handled by any of these CPUs except the ones that have been specifically shielded from interrupts. So in this case, 1 and 3. All right. Disk activity, just how busy are my disks? Network activity, packets in, packets out. Various looks into system memory are here, swap memory. Now, most of these things are system-wide. If I look here, most of these are system-wide views. There are a couple single process activity that are geared to a particular process or thread. So when I created this tab, I was asked, who are we going to look at? And what I end up with is basically a profile. So everything this thread has done since it started and how many times it did it in terms of system calls and API calls and routines, basically. And the percent of time it has spent doing that. Similar thing for a given process or thread, system counter things, CPU cycles, instructions, cache hits, cache misses. Somewhat hardware dependent. I'm on my laptop, so some of these fields aren't available for me. GPU stats. On the left, what my GPU is currently doing. On the right, GPU configuration. So what does my GPU look like? What does it support in terms of CUDA, lanes and warps and all that kind of thing? And on the far right, PCI bus configuration. So what's hanging off of the buses I have? What kind of devices, what IRQs are they tied to, that sort of thing. So nighttune is that tool that saves you from knowing all the command line ways to monitor what's going on your system. As an application developer, use nighttune to experiment with things like CPU shielding, interrupt vectoring, and process and thread affinity to find that perfect configuration that maximizes the performance of your application.